In this nugget, we're going to take a look at a concept called linked clones, which can help us roll out virtual machines much, much quicker and save tons and tons of storage. Let's begin. I'd like you to go back with me in time. Let's go back 20 years. And let's say we have a home and there's 5 people that live in this home. And let's imagine that all 5 of those people in this home want access to a dictionary. Now, one method we could use of supplying a dictionary for all these people is to give them 5 dictionaries. So there's dictionary 1, dictionary 2, dictionary 3, dictionary 4, and dictionary 5. Now, in this example, it might seem kind of a waste to have 5 separate dictionaries when they all could effectively share that one dictionary. It has the same information, they could all just use it. And if they wanted to make notes, what they could have is they could have a separate little scratch piece of paper or a notebook where they could keep their individual notes. And that way, what we could do is we could just share one dictionary that they all could read from. And again, if they wanted to keep separate little notes or keep track of things, they could do that on a little separate piece of paper. And that would be much more effective from a paper perspective, and from a book perspective, is to have one book be shared by all 5 people. Well, we have a very similar scenario in the world of virtual machines. In the office environment, we may have a need for each user to have their own virtual machine. No problem there. And associated with those virtual machines, they each have a hard drive, a virtual hard drive that takes up quite a bit of space. So if each hard drive was 10 gigabytes in size, we're taking a look at 50 gigs of storage just for their hard drives. But in reality, if all of those virtual machines are almost identical, there's a whole bunch of duplicated content on each of those hard drives. So here's an idea that you and I could do to save some space. Instead of having a separate hard drive for each and every one of them, why not take a common hard drive? And let's just refer to this as the base hard drive. We'll make it read-only. And let's say that is 10 gigabytes in size. And then what we can do for all the individual VMs is have them read from this base disk and then give them a teeny disk, thin provisioned, that they can use for writing to. And this is very similar to the concept of a delta disk when we take a look at snapshots. With a snapshot, we basically lock down the base image, and then we have a delta disk that we use for any changes since that previous snapshot. Well, in the case here, we could have this base image, have little delta disks for each individual VM. Well, check this out. If the delta disks are all like 1 gig each, we've now supported 5 virtual machines, and we're using 15 gigabytes of disk space as opposed to 50 gigabytes. And the users who are using these virtual machines wouldn't really know the difference. In the background, we're reading from the base image, and then we're making writes and changes to our delta disk. Well, the great news is we don't have to invent this type of scenario because it already exists as a feature of Horizon View. And it's called linked clones. And it's really easy to set up. What we're going to do is we're going to get a golden virtual machine. So let's say we have a VM sitting inside of vSphere. It's perfect. So that's our starting point. That's one. And then second thing is we're going to take a snapshot of that perfect machine. And now we have a snapshot. And then due to some additional software we're going to add, and that additional software is called Composer, Composer is going to take that snapshot and it's going to make a replica, which effectively is a base image that VMs can use. And this replica is a standalone entity. For example, once it's in place, we could go ahead and delete the VM and delete the snapshot, and this replica would still serve as the base image for our VMs. Now, we could delete the parent machine, this golden VM, and its snapshot, but it's more likely that we're going to want to take very special care so that those don't get disrupted. Because later, if we want to make a change or a tweak, we're going to go back to this golden VM, create a new snapshot to get everybody up to speed on the new changes. But the point I wanted to make is that this replica, once it's in place as the base image for these VMs with linked clones, is a standalone entity. It's not required to go back to the parent VM or back to the parent snapshot. It is, on its own, a full image that's ready to go. And again, the magic that creates that replica and allows us to use linked clones is a feature called Composer, which we're going to install. Now, while we're talking about this Composer software from VMware, we have a couple choices. We could install it on the vCenter server if it's installed on a Windows platform, or we could get another member server in the domain, and we could install the Composer software on that member server, and then we would simply, through the install, tell Composer exactly how to reach vCenter. Because they are going to be working together as Composer creates and manages the replicas and the details behind our linked clones. See, vCenter, on its own power, doesn't really understand linked clones, so it's Composer who's stepping in to make that magic happen. Now, for these individual virtual machines that we're going to be creating, these linked clones that share a base image that's based off of a replica, the individual virtual machines are going to have a delta disk, which they can write to. So any changes that are different from the base image, those would get written to the delta disk. That's separate and unique for each and every virtual machine. We also, on these linked clones, these virtual machines can have a persistent disk. So for example, Bob logs in for the first time. He gets automatically assigned to a VM. It's a linked clone. He can also be assigned a persistent disk associated with that. So for example, he goes into Windows Explorer, looks at his file system and sees, oh, I've got a D drive or an E drive. And that persistent disk could be used by Bob for whatever Bob wanted to write to that disk. Now, there is some data that happens when a virtual machine is running that we don't need to keep. For example, swap files. And there's also the option of a disposable disk that we can use as well that can contain the swap information. So, per its name, the disposable disk is disposable. So when the machine is turned off, that disposable disk information is not kept. And the last piece I wanted to chat with you about linked clones in this fundamentals discussion is the 3 R's: recompose, refresh, and rebalance. So let's start with recompose. Let's imagine that we deployed January 1st of whatever year, we deployed our linked clones. And then in February, there was a patch from Microsoft. And that may happen more than just once a month, but there's a patch that we want to deploy. What we could do is in February with that new patch, we could take our golden virtual machine. We could go ahead and apply that patch to our golden virtual machine, create a new snapshot. So for example, maybe the first one was snapshot A, and now we're going to create snapshot B. And then the recompose is to go ahead and create a new replica based on that new snapshot, which has the new patch that we just deployed. So the recompose is all about updating that base image that's being shared across the linked clones. The next R, the refresh, is telling a linked clone that it should resynchronize with the base image. So for example, let's say that this is Bob right here. Bob has logged on, and he's made several changes to his virtual machine. And those changes get written to the delta disk, which is no problem. However, if we force a refresh for that linked clone, what it's going to do is going to basically synchronize back to the point when we first started that linked clone before Bob made any changes. So in a kiosk environment, or we want to reset a virtual machine to its very first starting point every single time, we could go ahead and set up an option that says go ahead and do a refresh when the user logs out. So anything that the user did in their session is effectively going to be wiped out and reset back to that base image when they log off. And what this feels like, it feels like reverting to a previous snapshot. For example, we make a snapshot, then we make some changes, we revert to that snapshot. That's the same kind of look and feel. That's what the refresh is doing for our linked clones. It's resetting to the base image. And the third R is rebalance, which is going to redistribute linked clones among data stores. So we don't overload one data store and have it almost at capacity while yet another data store is sitting there almost empty. And I'll tell you one other major benefit that I love about linked clones. The very first linked clone that's created, it does take a while because it does have to make the replica, which is like a full image. So we're not going to save a lot of time in that first linked clone. However, for the second and third and fourth, they are very, very quick to deploy, the second, third, and fourth, and so on, compared to rolling out a full clone of a virtual machine. And again, the savings is that we're sharing this huge base disk, the replica, and that doesn't have to be recreated every time we roll out a new linked clone. In this nugget, we've taken a look at the concept of a linked clone. We're going to use an additional piece of software to pull this off. That's the Composer. We're going to share a base image and have delta disks for each of our VMs, and that'll save on storage. It'll also make the rolling out of these VMs much faster. I have had a lot of fun in this nugget. I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.